Hello viewers, this is Ronald taking you through today's tutorial on integration 1 and its applications. So today's lesson shall talk about area enclosed by the curve and the y-axis. So we shall start with problem 1. Problem 1 says that find the area enclosed by the curve y squared equal to x plus 9 and the y-axis by taking an element of area Roman 1 parallel to the x-axis and Roman 2 parallel to the y-axis. So we shall start with Roman 1, whereby you're going to use a strip parallel to the x-axis. The first thing is to get the intercept. So when x is equal to 0, y will be equal to plus or minus 3, and when y is equal to 0, it means that the whole of this will be equal to 0. Therefore, x will be equal to negative 9. So I've got the intercepts as y equal to plus or minus 3, 0, and also x, which is equal to negative 9. Now, when you sketch the curve will be in this form, and these are the intercepts, negative 9, negative 3, and positive 3. So when they want the area using an element parallel to the x-axis, I think this is the element parallel to this x-axis, and it's being form of a rectangle which will be equal to this length, which is x, and height and width, which is small change in y. So therefore the area of one strip will be x times small change in y. So that is this area of one strip equal to x times small change in y, but we know that y squared is equal to x plus 9, therefore x will be equal to y squared minus 9. Now the total area will be, now we can see that the small change in y has become dy, and this x is this x. But they say the limits from negative 3 to 3, so you integrate from negative 3 to 3 x with respect to y. But you can't integrate x with respect to y, so what you do, come here and substitute x in terms of y. So x in terms of y is y squared minus 9. That means that the integral will become y squared minus 9 from negative 3 to 3 with respect to y. When I integrate y squared, I'll come up with a third y cubed, and when I integrate 9, I'll come up with 9y. Next is to substitute the limits. So start with the upper limit where there is y, put 3. You'll come up with this bracket, then minus. Where there is y, put there negative 3. You come up with this bracket. And when I simplify, I'll come up with my answer as negative 36. Therefore, the required area is 36 square units on the negative side of the y-axis. So the negative sign here means that the area is on the negative side of the y-axis, as we saw in the sketch. Now we shall go to Roman 2. Roman 2, they want us to use a strip parallel to the y-axis. So let's draw, this will be the strip parallel to the y-axis. So the shape of the curve remains the same. The shape remains the same. This is a strip parallel. Therefore, the area, I think I realized that now we have 2y. There is this y above the x-axis and y below the x-axis. So the small change will be, the area of this one strip will be this 2y times this small change in x. Therefore, area of one strip is equal to 2y times small change in x. But we know that y squared is equal to this. Therefore, y is equal to plus or minus x plus 9 square root. Therefore, the total area will be integral from negative 9, this is negative 9 to 0, of 2y times dx, of 2y dx, which will give me, when I substitute for y, I'll come up with this. The 2 remains outside because it's a constant, and this one square root is the same as power a half. Now when I integrate this, inside the bracket is a linear function, therefore I can just use the normal integration whereby I increase the power by 1. When I say half plus 1 will give me 3 over 2, then divide by the new power, which is 3 over 2. And when I simplify, now 2 divided by 3 over 2 will give me 4 over 3, and this one will remain in the bracket, which is that. Now next will be to substitute the limits. So when I put 0 where there is x, I'll come up with this 27, and when I put negative 9 where there is x, I come up with 0. This 4 over 3 is this 4 over 3, and when I simplify, I'll come up with 36 square units. So now we shall go to area enclosed by the curve, the y-axis, and a line. So problem 2 will be, find the area enclosed by the y-axis, the curve y squared equal to x, and the line y equal to 3. So we shall first sketch the curve. So this is the curve y squared equal to 3. It has an intercept 0, 0. Now they want the area enclosed by this line y equal to 3 and the y-axis and this curve. I think consider the area enclosed is this. Therefore, we shall use a strip of area, a strip which is this with small change in y and x here. So this strip approximates a rectangle. Therefore, the area will be small change in y times x. So area over one strip is x times small change in y. But we know that y squared is equal to x, implying that x is equal to y squared. Therefore, the total area will be integral of x, which is this, dy, from 0 to 3. This 0, this is 3. But we know that x is equal to y squared, so where there is x, put there y squared. So now when I integrate y squared, I'll come up with a third y cubed. Then I put the limits 0 to 3. Now when I substitute the upper limit where there is y, I'll come up with 27 minus, substitute the lower limit which is 0 here to come up with 0. So this, when I simplify this, I'll come up with 9 square units, which is the area enclosed by the line y equal to 3, the curve y squared equal to x, and the y-axis. So now we shall go to area enclosed by the curve, the y-axis, and 2 lines. So find the area enclosed by the curve, enclosed by the y-axis, the curve x equal to 1 over square root of y, and the lines y equal to 2 and y equal to 3. So the first thing is to sketch the curve. Let us sketch the curve. So the shape will be in this form, and these are the lines y equal to 2 and y equal to 3. So the area they want is the area enclosed by the y-axis, this curve, and these 2 lines. I think I realize that that area is from here to there to here and that. So the area enclosed by this shape is the required area. So what we do, we take a strip which is this small change in y and x with dimension small change in y and x. Therefore, the area of that one strip will be equal to x times small change in y, which is that. And now that we know the area of one strip, we can get the area of the whole shape which is required, which will be equal to the integral from 2 to 3. 2 is this and 3 is this of x dy. So this small change in y becomes dy, we being equal to, but we know that x is equal to 1 over y, 1 over square root of y, which is the same as y to power negative a half. So where there is x, put there y to power negative a half. And when I integrate, I'll come up with this. When I increase the power by 1, so negative a half plus 1 will give me a half, divided by the new power, which is a half. So this 1 divided by half is 2. That is why you see 2 here. And next is to substitute, start with the upper limit. Upper limit where there is y, put there 3. We'll come up with, now this 2 is constant, I first put it out. Now when I put 3 here, I'll come up with 3 to power half, which is square root of 3, minus, then put the lower limit here to become 2 to power half, which is equal to square root of 2. And when I simplify this, I'll come up with my answer as being approximately equal to 0.6357 square units. So that is the answer that they wanted. Because now your turn to try the following problems. So hint is that. So when you try it out, you compare answers with that. So that is the hint. So try it out, compare answer with this. So compare answer with that. So that has been our lesson for today. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform. Thank you.